In this video, we continue to look at problem 51 from our textbook. In the previous video, we showed that 0 was an accumulation point for the set M, where the set M is the set of reciprocals of the natural numbers. In this video, I want to answer the question about whether or not 0 is the only accumulation point. And it turns out that if we intuitively look at the situation, it seems like it's reasonably clear that 0 should be. So here's the number line, and let's look at the situation informally. And here is 0. Now, the elements of capital M look like the following. We have 1, and then we have 1/2, and then we have 1/3, and we keep going, and eventually we will get down to a 1 over capital N, and then a 1 over capital N plus 1, and so on. And between each pair of these points, and let me clean up that denominator, that should look like a 1 over 3. Between each pair of these points, it seems intuitively clear that I ought to be able to put in a little delta ball where this is the only element inside the set M. But this informal idea is not enough to show that no other element is an accumulation point for the set M. So while I have an intuitive idea that 0 is the only accumulation point, I need to formally show it. So what I want to do on the next page is line up what it is that we're trying to do and get a strategy for accomplishing what we need to do. So our basic idea is going to be this. I want to let A be a real number, and I want to assume that A is not 0, and I need to show that A is not an accumulation point for the set M, which is the set of reciprocals of the natural numbers. Now, what that means is I need to think about what not an accumulation point means. And we've talked about that in class earlier. I need to show that there exists a delta bigger than 0 such that the punctured delta ball centered at A of radius delta intersected with the set M is the empty set. And I want to draw that on a number line to make it clear what we're doing. So here's the number line, here is A. And if I draw the delta ball, so here is my delta ball, the punctured delta ball has everything except A. So the punctured delta ball includes these elements and these elements. So I now puncture that delta ball. And the point is I want no element of M to lie in that punctured delta ball. So no element of M lies in the green stuff. A might be an element of M, A might not be an element of M, but that's irrelevant. I have to have somebody inside the delta ball that is not equal to A. And I want to prevent that from happening, so we want no element of M lying in that green area. Now, when I start to think about what I need to show, I want to realize there are a couple of really easy cases, and then there's one more subtle case. So we're going to break this argument into 3 separate cases. Case 1. A is actually less than 0. And what does that look like? Well, there's my number line. Here's 0. Here's A. And I want to remind myself that all elements of capital M are known to be bigger than 0. Remember, capital M is the set of reciprocals of the natural numbers. So they're all positive. And it's easy to put a delta ball over here if I let delta be anything that is less than the absolute value of A. Then the delta ball centered at A contains only negative elements. And that means that the intersection of the delta ball with set M is empty. And since the intersection of the delta ball with M is empty, that will also imply that the intersection of the punctured delta ball with M is empty. So case 1 is now done. Well, our second case is another obvious case. Let's pick a real number that is known to be bigger than 1. So here again, let's draw a picture about what this is going to look like. So there's my number line. Here's 0. Here's 1. And A is out here somewhere. And what I want to remind you is that since M is the set of reciprocals of the natural numbers, that means all of the elements lie inside the closed interval between 0 and 1. And because A is actually strictly bigger than 1, I can certainly find a little delta ball where the delta ball intersected with this closed interval over here is empty. In other words, I want to pick delta to be bigger than 0, and I want delta to be smaller than the distance between A and 1. And that will say that the delta ball centered at A of radius delta intersected with the closed interval between 0 and 1 is known to be empty. But that's enough to say that the delta ball intersected with M is empty. And that's enough to say that the punctured delta ball centered at A of radius delta intersected with M is empty. And so what we've managed to say is that A is not an accumulation point for M. The third case is 0 is less than A, and A is less than or equal to 1. This case is a little bit more subtle, and because of the length of the video, I want to do that case in the next video.